Hi everyone, today in Integrated Math 2 we're going to go over Chapter 5, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over a couple of the different postulates and just definitions in general. So our first one is 5.1. Through any 2 points, there is exactly one line. So we have point P and we have point R right here. If we connect them, they make a line. It's that simple. Then we have 5.2. Through any 3 non-collinear points, there is exactly one plane. So notice here, it says non. Non means not. And notice we have line and collinear. So they're not going to form a line. So as you see here, all 3 points here, A, B, and C, they're just in the plane. And it's one plane. Then we have a line contains at least 2 points. Well, it can have at least 2 points, but it can have more than that. So P, Q, and R. But it needs at least 2 to make a line, as you saw from 5.1. Then we have 5.4. A line contains at least 3 non-collinear points. Once again, non, and it has a line. So it's saying that this plane contains non-collinear points L, B, E, and C. 5.5. If 2 points lie in a plane, then the entire line containing those points lies in the plane. So as you can see here, points A and B lie on plane K, and line M contains the points A and B. So line M is in the plane K. Alright, let's go over a couple other ones. Intersections of lines and planes. So 5.6. If 2 lines intersect, then their intersection is exactly 1 point. They cross, they make the X. Well, it crosses only one time. And in this case, it's point P. Then 5.7. If 2 planes intersect, then their intersection is a line. So think about 2 papers connecting, and it's going to form that line right here. So as you can see, it's line W. Alright, then we have the midpoint theorem. If M is the midpoint, so midpoint, think of the middle point. On line AB, then AM is congruent to MB, which is true. This line just means congruency. So if this is 5 centimeters for AM, then MB must be 5 centimeters as well. So let's go over example 1. It says we want to determine whether each statement is always, sometimes, or never true and give an explanation for it. So we have, if points X, Y, and Z lie in a plane, so let's make a plane. Our plane is called plane R. We're going to say X, Y, and Z, just put in some random points. As you see here, they're not going to form a line, so it's non-collinear. Let's try making another plane. So we have plane R again, but let's say we had X, Y, and Z. As you see here, it could have made a line. This would make it collinear. Because col means with. So what we can say is, because we have 2 different examples, and you can see that they give us 2 different scenarios, we're going to say sometimes that X, Y, and Z are contained in the plane and has no bearings on whether these points are collinear or not. As you saw from our first one here, 1 and 2, it depends. It's sometimes true, it's sometimes not, depending on where we put our points. And then we have the next part, part B. It says for any 2 points A and B, there's exactly one line that contains them. Point A and point B, there are 2 points. Any 2 points can form a line. So in this case, it's always true, according to postulate 5.1, there's exactly one line through any 2 points.